All right, guys, 11.4a is volume of a prism. So we're kind of moving in a new direction now with volume. Volume is the space a figure occupies. So it's like what's inside. We measure it in cubic units, so feet cubed, inches cubed, centimeters cubed, that type of thing. And there was a mathematician, Cavalieri was his name, and he came up with this principle that says if two space figures have the same height, so two three-dimensional figures, same height, and the same cross-sectional area, so if you take a cross-section of the figures and they have the same area, then those figures will have the same volume. Okay, and I put a picture in, this is from your book. If you look here, this cross-section has an area of 6, this cross-section has an area of 6, and this cross-section, 1/2 times 6 times 2, also has an area of 6. So if their area is all the same and their height, this and this and this are all the same, then those three figures, even though they look totally different, have the same volume. There is a picture on page 1640. If you care to go look, it's not anything you have to do, but it just kind of walks you through an idea of this with Post-its, how that would work, just to give you a good visual. Okay, so volume of a prism. The formula we're going to be using is V equals BH, and a capital B is always, always, always the area of the base. Okay, whatever shape your base is. And then H is always going to be the height, is an H, sorry, of the figure. Okay, so we're going to find the volume of some of these. You'll probably notice these first ones are pretty familiar to you. A rectangular prism. Don't mind my drawing. I took my picture from my notes and I didn't draw it very nicely. Should look something more like that. Okay, so if we want to find the volume of this prism, we would find the area of the base times the height. Now, here's the thing with a rectangular prism. You may use anything as your base because it's 3 sets of congruent parallel figures. I tend to just use the bottom because I feel like that's what most people see it as. So if I want the area of this bottom rectangle, I would do 12 times 5. So my B is 12 times 5. And then my H is the height of the figure. That's always the distance between the two bases. So if these are my two bases that are parallel and congruent, then my height has to be this piece here, which is 6. So for that, I'm doing 12 times 5 times 6. When you plug that in, you can just plug it in as you see it. 12 times 5 times 6 is 360, and we were talking millimeters. And here's where you need to be a little bit careful. Volume is cubic. So make sure 360 cubic millimeters. Okay. Example number 2. Find the volume of the triangular prism. It's still a prism, okay? Here's where you need to be careful. What is your base in this figure? A lot of times people see this and they go, oh, so if I'm doing the area of the base times the height, my base is right here, and it is not, okay? Your base is not this rectangle. Your base is the two things that are parallel and congruent. So this and this make your bases. Okay, so that means if I'm doing the area of the base, I'm doing the area of a triangle, 1/2 base times height. So in this one, my 1/2 times my base times my height. Notice this is a lowercase b, this is a capital B, okay? My lowercase b right now is the base of my triangle, which I'm going to call 8. You could use 15, but I'm just going to use 8 as my base. And then my height is the height of the triangle, okay? That's 15. Okay, so this right here, that's capital B. Now here's what I need you to see. here's an H, here's an H. They are not the same H, okay? What you're gonna use for your second H is the height of the figure. And the height of the figure, so this H here, is always the distance between the two bases. Okay, so the distance between the two bases here is this 22. So we're gonna do the area of the base, which is this, okay, that's B, times the height, which is 22. Okay, and now here's the beautiful thing, we're multiplying, and you can multiply in any order you want. So you're gonna plug in 1/2 times 8 times 15 times 22 into your calculator, and the volume of this figure will be 1,320 cubic inches. Okay, so that was a little tricky. There's H's in places that's like, which H are we talking about? Which B are we talking about? Just make sure you take your time and think through what every variable means, okay? I highly recommend when you get to this B, you see what formula, say what formula you're using for that B also. All right. Okay, third and final example. Find the volume of the triangular prism. Let's see what we've learned. If I were you, I would pause this real quick and try it on your own and see if you get it. And if not, you can just real quickly erase and do it with me. Okay, but I'm gonna keep moving. You can pause me if you wanna pause me. So this one, triangular prism, which means your base is a triangle. Again, not this, not the rectangle. That is not a base, okay? So please don't use this as your base. You want to use as your base these two triangles. Okay, then the height is the distance between them. That's this, okay? So we're gonna find the area of our base, and notice our base is a triangle again. So we're gonna do 1/2 times the base times the height to find that setup. But right now, we don't know what the height of that triangle is. So I'm just gonna redraw the triangle. Notice this, my bottom is 8, my side here is 8, and then this 8 over here is this length over here too. So we have a triangle, an equilateral triangle. If I draw the height of that triangle in, what just happened to my triangle? I cut it in half, right? And equilateral is 60, 60, and 60. So now this got cut in half. So it's 30 and 30. This piece would be 4. So think 30, 60, 90 here. In a 30, 60, 90 setup, what is this gonna be? What is our height gonna be? It would be, did you get it? 4 rad 3. Okay, so if I'm doing B, I'm looking at this triangle, saying 1/2 times the base, which is 8, times the height, which is 4 rad 3. Kind of a lot there, huh? To get one little letter, to get a B. So if we simplify this, we're gonna leave this in simplest radical form. So 1/2 times 8 times 4 rad 3 gets you 16 rad 3. Okay, that's our capital B. A lot of times people are tempted to stop there because it's like, oh, I just did all this work. Oh, and I multiplied, so I'm done. That's just B, okay? We want the volume, which is B times H. So we're gonna take our B, 16 rad 3, and we're gonna multiply it by the height of the figure. And if you go back up here, remember the height of the figure is this 10. So we're gonna multiply by 10. Simplest radical form says we go 16 times 10 is 160, and then multiply by rad 3, and we're talking inches. So this is gonna be cubic inches, okay? sometimes they're going to ask you to round. If they ask you to round, you can just plug this in. So if we were going to round this one, you would do 160 times rad 3. That comes out to 277.1 cubic inches. Okay, so just be careful. Volume is always cubed. Area is always squared. Okay, that's it.